Now we shall extend the previous problem to bit more. Let us say I want to construct a DFA which accepts set of all strings over a comma b, this is same, in which number of a's is, let us say a's is divisible by 3, which means if I take number of a's and in a word and if I divide it with 3, then the remainder should be 0. It is nothing but number of a's in the string is divisible by 3 and number of b's is divisible by 2. So if you look at the previous diagram, we have constructed two DFAs. One is for the first one, number of a's, and other is for the second one, and then we applied the cross product. We are going to do the same way, we are going to do the same method, but only difference is I am not going to actually find the cross product and apply it. So if you can remember it, previously if there were two states in one DFA and two states in other DFA, the final output is containing 6 states, right? And we counted number of a's horizontally and number of b's vertically. Now I am going to do the same method, but then the states are going to vary. Maybe you can just try and guess the number of states in this DFA. The number of states in a DFA where one DFA is containing m number of states and the other DFA is containing n number of states. If you take the cross product, the final answer should be m by n. So in this problem, if this one is containing 3 number of states and if this one is containing 2 number of states, the final answer should contain 3 into 2, which is 6 states. So I am going to count number of a's horizontally and number of b's vertically. Okay, remember I am going to count number of a's horizontally, number of b's vertically. So number of a's have to be multiple of 3. I am going to count a, 0 a's, 1 a, 2 a and 3 a's. Similarly, I am going to count number of b's vertically, 0 b's, 1 b, 2 b's, 3 b, which means even b's, odd. So it is nothing but only divisible by 2 and not divisible by 2. So b's will be only 2 states and a's will be 3 states. Why? Because number of b's have to be divisible by 2, that is by only 2 states, and number of a's have to be divisible by 3, that is by 3 states. Okay. This horizontal loop is counting the a's and this vertical loop is actually counting the b's, number of b's. Now let's talk about each state. You can see what does each state indicate. This state, so this state indicates 0 number of a's and 0 number of b's, which means this state indicates 0 0, which means 0 number of a's and 0 number of b's, that's it. And this state indicates 1a and 0 b's, and this state indicates 2a and 0 b's. And even if I come back like this, look at this, 0 a's, 1a, 2a, 3a's. Now again divide the 3 by 3, so you will again get the same 0. Just try to understand this way. When I say it is 0 number of a's, it is actually the number which when divided by 3. So this state indicates 0 number of a's, 1a, 2a and again 3a's. 3 when divided by 3 is going to give a remainder of 0. That is how I got 0. Okay. And now this state indicates 1b and 0a's. This state indicates again 1b, 1a. 1b, 1a, and this state indicates 1b, 2a's or 2a's, 1b, or let's write number of a's first instead. So I am going to write number of a's first and then number of b's. Here each one indicates, this one indicates number of A's, and this one indicates number of B's. Number of A's, number of B's, number of A's, number of B's. So here number of A's is going to be 0 and number of B's is going to be 1. Here number of A's is going to be 1 and number of B's is going to be 0. Here number of A's is going to be 2 and number of B's is going to be 1. Check it. So in order to reach this state, I have to see 0A's and 1B. In order to reach this state, I have to see 1B and 1A, 1A and 1B, or 1A and 1B. In order to reach this state, I have to take 2A's and 1B, or 1B and 2A's, or 1A, 1B, 1A. However, I am going to get 2A's and 1B. And when I write 0, 1, 1, 0, 2, 0, all these numbers are actually mod 3 numbers, which means count the number of A's and count the number of B's and then take mod 3. So these are actually not the exact count of number of A's and number of B's. It is the count when I divide by 3. For example, when I say 0, 0, it is nothing but number of A's and number of B's when divided by 3 is going to give a remainder of 0, 0. So understand this diagram. Now if the question is number of A's has to be divisible by 3 and number of B's have to be divisible by 2, then it is going to be, this one is the final state. See, this first number is going to indicate number of B's when I divide it with 3, and second number is going to indicate number of B's when I divide it with 2. Why? Because A's are being counted here like mod 3 counter, and B's are being counted here like mod 2 counter. Even this is a mod 2 counter and this is a mod 3 counter. Okay, so how many states did we get? 6. Remember that. Okay, now if they ask like this, the question is number of A's in W mod 3 is greater than or equal to number of B's W mod 3. If the question is like this, number of A's in W mod 3 is greater than or equal to number of B's in W mod 2, which means what are the states in which A's are more than B's taken mod 3 and mod 2. See this is the state in which A's are greater than B's taken mod 3. Therefore final state has to be 1, 0, and this is the state in which A's are greater than B's taken mod 3 and mod 2, which means 2, 0 is the final state, and this is the state in which A's are greater than B's taken mod 3 and mod 2, so 2, 1 is the final state, and this is the state in which both are equal. Therefore 1, 1 is also going to be the final state. That is how I should be filling, right? What if it is number of A's in W mod 3 is equal to number of B's in W mod 2, which means both of them have to be equal. So they can be 0, 0 or 1, 1. That is the only case where I get equal. Therefore 0, 0 and 1, 1 are going to be the final states. See, these are the final states for this question. And what is the final state for this question? Obviously 0, 0. Right? So you can extend this question, you can use your imagination and you can extend this question to any level. Okay.